Alright, you guys, so I want you guys to watch this video and complete the questions below, and I want you guys to draw what I'm drawing in your notebook, just so you can keep it. This will be the type of stuff that's on the quiz. So, first things first, it says count the number of bonds you have to break in the reactant. So, I'm going to go ahead and start by drawing out the reaction. Get over there. For cellular respiration. Sorry. So, we've got C6. H12O6, this is glucose, plus 6 oxygen, and oxygen looks like this, O2, and that goes to 6 carbon dioxides plus 6 waters. Okay, and these are called the reactants because they're reacting together. I spelled that wrong. And these are, I was going to spell reacting, and these are called the products. Okay. All right, so the first thing I'm going to do is I'm actually going to draw these guys out because I'm not really, I don't want to, what I'm going to do is I'm going to be building something with my actual, my Mike and Ike's, but I'm going to first start by drawing like my rough draft out here. Okay, so I'm going to represent, make sure I'm in here. So I'm going to represent, the orange is going to be oxygen. My green is going to be carbon. And my red will be hydrogen. And I will represent my bonds or my toothpicks by drawing a line like this. Okay, a bond, this is 2 electrons, right? Okay, so first things first, I do not expect you to be able to do this on your own. I'm just drawing it. The biggest thing is I'm showing you the big picture here. I do not expect you to be able to draw this on your own. So I got 6 carbons. So 1, 2, 3, 4, 5, 6, and those actually all go in the middle like that. Okay, and then I have to put in, so 6 carbons, and I'm going to put 12 hydrogens in on this side. Okay, I'm just going to look on this side. This is the reactants. So again, I don't expect you to know where these go. I'm actually showing you where they go. 3, 4, and we'll go, I'll put one right there, 5, 6, 7, 8, 9, 10, 11, 12. I should have put my oxygens in first. Okay, so then I'm going to go ahead and put my oxygens in. Those are going to go right here. Okay, and I'm actually going to put them right here, right here, right here. How many oxygens do I have? I am going to have 6 oxygens in this one. 1, 2, 3, 4, and then 5, one right here, and then one right here. Now you might be like, Miss Moore, how do I know this? Well, I drew out the Lewis dot structure previously, right? It looks like this, okay? And I'm not requiring you to know how to do that. I'm just showing you what it would look like at the end. So these are all connected here, okay, like that. And these hydrogens are also all connected. Okay, now this oxygen and hydrogen are connected here. Oops. That one's connected here, that one's connected here. This is actually a double bond. That's connected, that's connected. Oops, did I do that one right? Oh, that one should not be connected right there. Let's see, boom, boom, boom. Ignore that one, get rid of that one. Boom and boom, boom and boom, boom and boom. Okay, so this is what this looks like. And just a little background, this is glucose. there's different types of sugar: glucose, fructose, lactose, which we find in milk, and fructose, which we find in fruit. Glucose is the simplest sugar. It's what everything gets broken down to. Again, our body takes the food and we break it down into this. Why is that so important? Well, we use this plus oxygen, which we breathe in order to make energy. Oh, I forgot the most important thing. Plus energy. And this energy is in the form of ATP. Okay, now we'll talk about where that energy comes from. So I've got my glucose, and I'm going to say plus. So notice how I've got 6 carbons. Okay, 1, 2, 3, 4, 5, 6 carbons. This is like an advanced Lewis dot structure. And we have oxygens, we had 6 of them here. 1, 2, 3, 4, 5, 6. And hydrogens, we have 12 of them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Again, this is my rough draft. I'm actually going to build these over here with this one. Now, you might notice, Miss Moore, you forgot to draw your electrons on here. You're right, but I'm just going to keep it simple. I'm not going to draw them on there. Technically, there would be, two here and 2 there, 2 here and 2 there, but I'm not going to draw them on there. Okay, and same for this. I'm going to make, I'm going to pair up oxygen. Okay, it says O2, so I've got an orange oxygen right here. 1, 2, and we're going to do 6 of them. That's what it tells me. Now, again, you haven't learned how to do this yet. I'm actually just showing you for the first time right now. But you can kind of pick it up. Okay. All right, and if I was to draw the Lewis dot structure for these would have double bonds. We'd have 1, 2, 3, 4, 5, 6, 7, 8. I would have 2 pairs of electrons on the outside, but again, just to keep it simple, I'm not going to draw those. Okay, and again, I would not expect you to do this. I'm just showing you. We're just trying to answer this question. Count the number of bonds you have to break in the reactants, and then the same thing for the products. Okay, so let's go ahead and count over here. All right, so we've got, let me go ahead and use my yellow. So for my reactants, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 20. Oh, did I forget one? Let me double check. 1, 2, 3, 4, 5, 6, 7, 8. Oh, 9. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Whew. I was like, I forgot one. Okay, so we've got 24 bonds here. Okay. And then here we've got 2, 4, 6, 8, 10, 12. Okay, so then plus 12 here. Okay, so for our total over here, this plus this, that's 36. So we've got 36 bonds. So right here, for number 1, count the number of total bonds you have to break in the reactants. Okay, I'm going to go ahead and put 1, like that. Okay. Now I'm going to go ahead and start building this. I don't know what it's going to look like here. I'm a little nervous. It's probably going to take me a long time. It's not easier. Let's do it. Okay. All right, last one. These poor guys are gonna be tore up. The real shame is I have a whole bag of miconite because I'm not gonna eat because I don't eat that kind of stuff. I'll just save them for next year. That's kind of gross. Okay, so here is our glucose molecule, and we have let's go ahead and count the red. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so for our hydrogen over here, we have 12. Where's my pen? Here it is. Okay, so over here on this side, we have 12. Our oxygen, we've got 1, 2, 3, 4, 5, 6. And our carbon, we've got 1, 2, 3, 4, 5, 6. Okay, all right. And how many bonds do we have? We said we had 36 bonds. Okay. Okay, so count the number of bonds you have to break in. Oh wait, I forgot over here. I didn't do these ones yet. Okay. So now I'm gonna go ahead and do boop, 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 boop. So I did 1, 2, 3, 4, 5, and 6. All right, you guys, we're almost done. There. So here we are. So we have move this over. So we have our glucose molecule here, all of its glory. Okay, and then we have 1, 2, 3, we have our oxygen. So here's what happens. So in glycolysis, the cellular respiration, we eat our food and our food is broken down into glucose. And when we breathe in oxygen, these two things combine. And what happens is we have, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36 bonds here. And all 36 of those bonds, 36 of them, have to be broken. And these are all going to be rearranged. All of these atoms rearranged to form 6 carbon dioxides and 6 waters. Now, the energy that is produced during this process comes from breaking the bonds. So it literally, you guys are gonna hate me, it literally takes me energy to break apart these bonds and create these new ones. And when I break these bonds apart and I create that new ones, it creates energy. Okay, give or take. And so what am I going to do here? Let's go ahead and draw our rough draft. We are in a moment going to take these elements that we have, sorry, not elements, these molecules that we have, and we are going to break all of the bonds that we just worked so hard to do, and we're going to recreate them. And you'll see that we are going to have the same exact number of every single one of these atoms is going to get used, and every single one of these bonds is going to get used. They're just going to be rearranged on this side, but we have the same number of atoms. Okay, we're going to have the exact same number here and the exact same number here on this side as we do the products. Okay, let's go ahead and check this guy out. All right, so we are going to create 6 carbon dioxides. Carbon is green and oxygen is orange. So green and orange. And I'm gonna go ahead and do those right here. So I'm gonna go ahead and do, so it's 1 carbon and 2 oxygen. So we're gonna put carbon in the middle. So 1, 2, 3, 4, 6 of them, 5, 6. And it has 2 oxygens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh wait, is that right? Oh, 11, 12. Okay, I lied over here because over here I said 6 oxygens, but check this out. I forgot that we have to add these up. So 1, 2, 3, 4, 5, 6. That's 6 plus 2, 4, 6, 8, 10, 12 plus 12. That gives me 18 total. My bad. Okay. So over here on the reactant side, we had 12 hydrogen. we had 18 oxygen altogether, and we had 6 carbon total. So let's go ahead and continue over here. So it says that everything we have here, this plus this, is going to be reformed to create this. Okay, so bada boom. Oh, you know what? I actually forgot. This is a double bond. Carbon has 4 valence electrons, and 1, 2, 3, 4, and you can see that carbon has 1, 2, 3, 4, 5, 6, 7, 8 here. And then if we're drawing this in the real world, we draw 2 pairs, lone pairs over on that side. Okay, it'd be boop, boop, boop. Like that. Okay, but we're not going to do that because that's way too much drawing. Okay, so what we have here, all of these guys and these guys, we're going to break all of those bonds and we're going to recreate this plus 6 H2O water molecules. Okay, so we have oxygen in the middle here, so that's our orange. Okay, 6 of them. 1, 2, we'll probably made that too big. 3, 4, 5, 6, and then we have our hydrogen. Hydrogen is red. Where's my red at? There it is. Okay, and the way that water forms, it forms like this. It's bent. I'll show you guys. And of course, I don't expect you to know how these form, okay, but you guys have the background to help you understand what these things represent. And really, there's 2 electrons right there. 2 electron pairs. 2 lone pairs. 1, 2, 3, 4. Okay. And hydrogen's happy because hydrogen only wants 2 electrons shared. Okay, so let's go ahead and do this. So we have to literally break all 36 of these bonds to recreate this over here. All right, so what I'm going to do is I'm going to start off by, I'm going to literally break these bonds here. Miss Moore, all of your hard work. I'm going to keep these guys over here. And you're going to see that mass, because all these guys have mass, 1, 2, 3, 4, 5, 6. Mass is conserved. It means it's saved. We don't actually lose any mass. All of the elements that we had before. I got to keep track of all my bonds here. Okay, everything's going to have to be accounted for. Oh my gosh, these poor things. Okay, they're being destroyed. You know what? Let me just go ahead like this. My hands smell good. Okay, I gotta keep them all around. Okay, because I have to do something with every single one of these atoms. I don't get to add new ones in. I have to keep with what I have. Okay, I don't get to add atoms to this. We take exactly the same amount of bonds and atoms we had before, and we recreate carbon dioxide, which we breathe out, and water, and what's most important is energy. Okay, so 1, 2, 3, 4, 5 more. So 1, 2, 3, 4, 5, and here's our last one. Oh, it's gonna be the only one that's not the same size. Dang it. Okay, well, this is not drawn to scale, as you guys can see. Okay, boom, there it is. All right, so we had to break. Okay, let's do some counting, some counting here. So again, let's see how many hydrogens we have. 2, 4, 6, 8, 10, 12. So over here on this side, we have 12 hydrogens again. That checks out. And then oxygens, we're looking for 18. 2, 4, 6, 8, 10, 12, 13, 14, 15, 16, 17, 18. Again, bada boom. That checks out. And then carbon, 1, 2, 3, 4, 5, 6. That checks out. Okay, and let's count the bonds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36. And again, we have 36 bonds. So we had to break, and then in order to make, and in that process, we get energy. Voila. So what the heck do we do, Miss Moore? So now that you watched the video, you count the number of bonds you have to break in the reactant. So how many reactant bonds did we have to break here? We have that number right here. Okay. And then number 2, count the number of bonds you formed in the products. We have that number right here. Bada boom. What is the same and what is different about the bonds on both sides of the equation? So go back and look at what types of bonds did we have? We call these single bonds, these double bonds, and talk to me about what was the same, what was different. There you have it.